Hello students, under the lesson of similarity, we are taking the revision of lesson number first. Yesterday we took the revision of these points, that is the ratios of areas of two similar triangles. Then we saw its examples based on that properties, and we saw the BPT theorem. Okay, it is very important theorem. And then Converse. After that, this is the activity is given here, and this part is deducted from our syllabus, that is angle bisectors. This part is not there for the syllabus. Okay, after that, after this part, property of the angle bisector of triangle, this part also omitted from the syllabus, means this will also not come in exam, in board exam also. Then this, remember this point is also. Afterwards, the next theorem, that is converse of angle bisector, it was also deducted from the syllabus. Three parallel lines also will not come in exam. And then the next, from page number 11, that I will send you the screenshot, I will show you. Otherwise, this theorem was also means this page was reduced. This will not come, that will not come, okay, in exam. Then these two are upsides, it is important. Then next, that is solved examples are there. And which solved examples are there? This. So under this you have to study which examples from this that I made. So this is the reduced syllabus, that is geometry standard 10, and I told you I will send you, I send this PDF on your on our group. Then also from the page number which they told you here, solved examples and activity from page number 12. Solved examples and activity from page number 12, it was cancelled. So here it is page number 12. Okay, and from this solved examples, all solved examples and activity, this also was deducted from your syllabus. Okay, so these all things are there, it was deducted from our syllabus. Okay, then next, then from the page number 13, that activity just now I shown, it was deducted, and the reduced from the syllabus. And then afterwards, page number 13, problem set, practice set number 1.2, inside first and second question is there for the exam. And after that, you just see page number 14 and 15. Page number 14 and 15. So here it is page number 13. These two examples are there for exam. This was this and that. Okay, but page number 14 means from this page number 14, question number 3rd, it will not come for exam. Then 4th will come. Afterwards 5th was deducted from the syllabus, this was deducted. 6th was deducted. Then 7th, it is the based on three parallel lines property, angle bisector property, so this was also deducted. Then afterwards, page number 15, this 8th question was not there for exam, 9th was not there for the exam, 10th is there for the exam. So this question will come for, you have to study these questions. After that, question number 11, it was also what happens, cut from that syllabus. Okay, now next point is the similar triangles, that we will take the revision. So similar triangles, when we say that two triangles are similar to each other, as we know that congruency inside we have studied that when two triangles are similar to congruent to each other, when it's all angles and all sides when its all angle and all sides are congruent to each other. Then we say that these two triangles are congruent to each other. But in similarity of triangles inside, if two triangles are similar to each other, their all angles are congruent to each other. For example, if you see here, say shown by same sign here. So B is congruent to E. B is congruent to E. A is and D sign is same. So A is congruent to D. And at last C is congruent to F. C is congruent to F. Okay, means its all angles are congruent to each other and ratios of their sides is equal. Okay, means AB upon DE is equal to BC upon EF is equal to AC upon DF. Then means its angles are congruent to each other and its sides are in proportion. A ratio of their sides is in proportion. Then these two triangles are similar to each other. Okay, and which are those two triangles? That is triangle ABC similar to triangle DEF, and correspondence of this what vertex of the triangle must be what happens must be joined to each other. Meaning of it is, if A is congruent to D, then A and D must come at the time of writing similarity of the triangles. What we have to write it at particular, means A is congruent to D, so A and D will come in first places. If B is congruent to E, then they will come in second. In that way we have to arrange it in a particular manner. Next we will see the test of similarity of a triangle. Okay, so inside it, when two triangles are similar to each other, for that how the test of congruent triangles test are there. In that way there are some tests by using that we can say that two triangles are similar to each other. So first test is the AAA test of a similarity of a triangle. AA test of similarity of a triangle. If the what they do for a given correspondence of vertex. So here given correspondence of vertex when corresponding angles of two triangles are congruent to each other, means A is congruent to P, B is congruent to Q, and C is congruent to R. If A is congruent to P, B is congruent to Q, C is congruent to R, then these two triangles are similar to each other by which test of similarity? That is A test of a similarity. If you see here, A is at first position and A is congruent to whom? P. So A and P these are at first places they had taken. Afterwards B is congruent to Q, so B and Q at second place. And lastly C is congruent to R, so C and R are at last. So this is called as a correspondence. Means A is congruent to D, P, means A is congruent to P, means correspondence of A is with the P, B with the Q, C with the R. Okay, so you can write this in that way. A, C, B, if we are writing A, C, B, then here you have to write A, C, B, then here you have to write P, R, Q. Triangle P, R, Q. Sorry, here similarity we have to give. So triangle ACB similar to PRQ. Triangle ABC similar to PQR. Otherwise triangle BCA similar to QRP. In that way its writing we have to write. Okay, now the next point for more information, that AA test of similarities it is given, means all angles are proof given it is. So if all angles of a triangle are congruent to the all angles of remaining another triangle, then these two triangles are similar to each other. Let us assume that ABC is bigger, we have to take, and after that point M is there. So we have to mark here point M and N such that PQ is equal to AM and PR is equal to AM. In that way we have to do this, mark this point and join AMN. Now here are two triangles. Which are those triangles? AMN and ABC. From these two triangles inside we have to show AMN and PQR what? Congruent to each other. They are congruent to each other because all sides are congruent to each other. Their ratios of sides are congruent to was equal, means AM upon MB. AM upon first of all they use here BPT theorem, that is AM upon MB is equal to AN upon NC. Next what they had done here, they use the property of componendo. So here what they MB is plus AM upon AM, numerator plus denominator upon denominator. Same here, then AM plus MB is equals to AM plus MB is equal to AB, AN plus NC is equal to AC, that we have to write here, okay, and they are divided by AM upon NC. Now if you AB upon AM, AM is equals to, what is the measure of AM? Measure of AM is equals to PQ and AN is equal to PR. So replace AM with the PQ and AN with the PR, then you will get here, that is AB upon PQ is equal to AC upon QR. Means these two are the ratios of their side and one angle already congruent to each other, and that's why what happens. Similarly we can show that AB upon PQ is equal to BC upon QR, means it's all sides are sides ratio is in correspondence with each other, and that's why these two triangles are similar to each other. That is for more information, but such a type of questions are coming in the exam, okay, so you have to study this also. Next it is AA test of similarity. As we know that all angles of a triangle are what? Sum of all angle of triangle is 180 degree. And suppose I drawn here two triangles, that is this is triangle ABC and this is another triangle ABC. This is ABC and that is PQR. And if this measure of angle is how much it is, suppose 70 degree, and this is also 70 degree, and this one is the suppose 50 degree, this is 50 degree. If you do the addition of this both is equal to, you will get 70 plus 50 is equal to 120. According to the rule or property of a triangle, sum of all angles of triangle is equal to 180. If you do the subtraction of this, you will get here answer 60. So C is equal to 60 and R is equal to also 60. And when the two angles of a triangle are congruent to each other, definitely the third is also congruent to each other. That's why we can use AA test of similarity of the triangle. Okay. The next here they gave us, we know that when given correspondence of vertices, when two angles of a triangle are congruent, the two corresponding angle of another triangle, means one triangle's first triangle's two angles are congruent to the another triangle's two angle, then remaining angle of first triangle is congruent to remaining angle of second triangle, then remaining angle, okay, this is A, B, C, and that is what I told you, PQR. If A is congruent to P, if A is congruent to P and B is congruent to R, then C is also congruent to angle R. Understood? So that is the AA test. This means that when two triangles of one triangle are congruent to two corresponding angles of another triangle, then the condition is sufficient for the similarity of two triangles, and this condition is called as a AA test of similarity. Okay. Now the next that is the SAS test of similarity. As I told you, if the two sides, if you see here in the figure, KL upon RS is equal to LM upon ST. KL upon RS is equal to LM upon ST. So if you find its reduced form, you will notice that it is 2 upon 3. then and the angle in between these two sides, means angle L is congruent to angle S. If such a condition is there, then these two triangles are similar to each other by SAS test of similarity. So here what they give us, for a given correspondence of, for a text, so if two triangles, if two pairs of corresponding sides are same in proportion, so here pairs of corresponding sides are in proportion, and angle between them, so which is the angle between them, L and S, okay, are congruent, then these two triangles are what, similar to each other. Understood? So this is about SAS test of similarity. Next it is the SSS test of similarity. Inside it, what they told you, for a given correspondence of vertices, for the given correspondence of vertices, if two triangles, when three sides of triangle are in proportion with corresponding three sides of another triangle, means here sides which are there, PQ upon YZ equals to PR upon XZ equals to QR upon YZ. If this is there, the ratios of corresponding sides of a triangles is equal, then the given triangles are similar to each other by SSS test of similarity. So we saw here AA test of similarity, then SAS test of similarity, and SSS test of similarity. Okay, now and next it is the what, properties. Every triangle is similar to itself. This property is called as a reflexivity, means ABC is similar to ABC only, it is called as a, this property is called as a reflexivity. Next, if ABC is similar to DEF, DEF is also similar to EF, ABC. DEF is also similar to ABC, and this property of a similarity of triangle is called as a symmetry. What I said to you, if ABC triangle is there, if ABC is similar to DEF, then DEF is also similar to ABC, and this property is called as a symmetry. And the last third, that is if ABC is similar to DEF, DEF similar to GHI, then ABC is also similar to GHI. So for that I told you, if first triangle is congruent to second, second is congruent to third, then first and third are also congruent, similar to each other. Okay, so in that way you have to solve this. Okay, use this properties and the similarity of a triangle, and you have to solve the example based on it. Here it is very easy. If you see in the figure, here y is equal to 100 given, and z is equals to how much given, 30 given, 130, and here also m's angle measure is 100 degree and it is 30 degree. So these two triangles are similar to each other by which test they are asking. Is they similar to each other? Yes, they are similar to each other, and just now we studied that these two triangles are similar to each other by which test of similarity. If you see here, y is congruent to angle y is congruent to angle M, and angle N is congruent to angle Z, then these two triangles, that is triangle XYZ, is similar to triangle LMN by which test of similarity? AA test of similarity. Here it is angle and here it is angle. So they are congruent to each other by AA test of similarity. After that, the next question is the second question. Are the two triangles from figure 1.51 are similar? Is they similar? And according to the information given, if yes, by which test? So for that we have studied the different similar test of similarity. So here if you see, if you find the ratio PM upon UV, PM upon UV, then you will get it here 6 upon 3 is equal to 2 upon 1, and Mn upon VW, Mn upon VW is equal to 10 upon 5 is equal to 2 by 1. So here the ratios of side, that is PM upon UV, is equals to Mn upon VW. So it is equal, and the angle between them, means which is the angle, M is congruent to V, and this angle is there, it is the in between the sides which are in the whose ratios are same. So these two triangles are similar to each other by which test of similarity? That is yes test of similarity. Understand? So we have to write in this way. First of all, show the sides are ratios of sides of corresponding sides is equal. Then angle show congruent, and then these two triangles are similar to each other by SAS test of similarity. Can we say that the two triangles in the figure 5.52 similar? Are they similar? That is the question. So first of all, and if similar according to the information given, if yes, by which test? That is the question asking to us. So first of all, if we see here, if we find the ratio of xy upon mn is equal to 2 by 3 and yz upon np is equal to also 2 by 3, means ratios of corresponding sides is same. Okay, 2 upon 3 and 2 upon 3. Okay, but here it is given z is congruent to p. Z is congruent to p and z and p are not included angle. If this is not included angle, means which is the included angle by these two sides? That is y and n. But these two angles congruence is not given, but instead of this which given? Z and p given, and that's why these two triangles are what? Not cannot be said that they are similar or not. Okay, now the next question, that is this is the activity it is given. What is the question? In the adjoining figure, BP is perpendicular on AC, CQ is perpendicular on AB, and here they gave between is A dash P dash C, A dash Q dash B. Okay, and we have to prove that APB, this is APB triangle, and AQC, these two triangles we have to show similar to each other. How we can show? If you see here, these are here it is right angle and here it is right angle. So APB is equal to 90 degree and AQC is also 90 degree. Okay, then, and this is the common angle which APB is congruent to AQC because both are 90, and this angle is a common angle in between them, and that's why what happens, these two triangles are similar to each other by which test of similarity? That is common angle. Okay, so these two triangles are similar to each other by a test of similarity. And at last, the fifth question, diagonals of quadrilateral ABCD intersect Q at point Q. They intersect if 2QA is equal to QC, means QA's double is QC, and 2QB is equal to QD, means QD is double the QB. We have to show that CD is equal to 2BE. So given is written here, to prove is written here. So first of all, we will find the ratio of QA upon QC. QA upon QC is equals to, from here by taking this we have to find QA upon QC is equal to 1 by 2. This take ratio and find QB upon QD is equal to 1 by 2. If it is same, 1 by 2, their ratios are equal. Therefore, QA upon QC is equal to QP upon QD. After that, what we have to show? We have to show these two triangles. Which two triangles? AQB and CQD. This AQB and this CQD triangles we have to show similar to each other. Just now show these sides are similar and this is the vertically opposite angle, that is BQA and CQD. They are congruent to each other. Okay, and therefore these two triangles are similar to each other by SAS test of similarity. Once they are similar to each other, their remaining sides also what happens? Similar to each other. So AQ upon CQ is equal to QB upon QD is equal to AB upon CD. So here AB upon CD equal to, we have to take 1 by 2. This 2 is there, it will come here for multiplication and CD will goes here for the multiplication. So we got here 2AB is equals to CD. In that way we have to solve this. Today you have to solve the practice set number 1.3, and today whatever I taught you, it's a revision you have to do. Understood? And And the reduced syllabus I am going to, I already sent, today also I will send, and as per it you have to do the study for the exam, that is the unit test. Okay, so today we will stop here only. Okay, thank you and have a good day.